Hi, it's Jan Beta, and today I'm going to do a full restoration of this Nintendo Super Nintendo, or SNES, or SNES, whatever you prefer to call it. This works fine, as you've seen. Played some Parodius there. It has seen better days, though, optically. It's pretty dirty and yellowed, and also there are some things internally that we need to take care of to make this last for a bit longer than it probably would without us taking care of it. Namely, there are surface mount capacitors in here that need replacing. This is an early 90s console, and basically all surface mount electrolytic capacitors from that era are not very good, and they tend to leak over time. And also, this is now more than 30 years old, so it's going to be a good idea to take a look inside and replace some capacitors anyway. So that's what we're going to do today. And the first step, of course, is opening this up, which is not super trivial, because you need a special screwdriver for that. These are unlike any other screws, basically, and these are game bits. These were also used in different sizes on the cartridges from Nintendo and Sega, actually, and probably some other manufacturers also used these for their gaming console. It's pretty specific. These are 4.5mm game bit screws that we have to remove here, and thankfully I have a screwdriver bit for that. And there are 6 of these game bit screws on here that we should be able to remove. Oops, something broke. I think a screw standoff just broke off. We're going to have to see if we can fix that. We broke something off internally. But now this should just lift up. Ta-da! There are some revisions that have a separate, I think, sound and video board, but this is a slightly newer variant, I think. My standoff completely broke off here. That's what happened. That's my screw post. Yeah, that's 90s plastic. It's very brittle, of course. Yeah, now we're just going to have to remove all the Phillips screws in here and the little fluff bolts. This is our power switch that plugs in here. We can unplug that and put it aside. See, I'm not sure if these screws are all the same size. So far, looking good. This is our spring-loaded eject mechanism, which literally just pushes the cartridge up. It's not very fancy, but I guess at the time it was a nice feature. So we can lift this out on this side, and we should be able to remove it. Yep. We can also get this front part off by just removing this little flat flex here from its connector. More screws. We have 2 here that look different. They are silver instead of brass colored. And these are actually a bit longer, so I'm going to have to remember that. And these are the same here. Okay. So 2 types of screws. Cartridge port screws, and the ones for the connectors in the back here to hold those in place are longer and silver colored, and the rest of them are all the same length, brass colored. Now we can take this whole portion of... look how sticky this is. We can take the whole circuit board out here, and we are going to have to remove the shielding. I think this just clips in. Yep. And this is screwed down from the backside and also on this little voltage regulator. There are several different revisions of these boards, actually. This appears to be a newer one, but I'm not an expert. CPU-01 SNSP 1992. So this is, of course, a PAL version. This was released first in Japan in 1990 already, I think, and then in America in 1991, and then most European countries got it in 1992. At least here in Germany it wasn't released until, I think, August 1992, which is kind of strange comparing it to the release cycles of modern consoles these days. Yeah, There were some years between the release in Japan and the release in Europe. So we're going to have to remove this to get to the capacitors, which are mostly under here. Yeah, the board from the backside doesn't look very nice because Nintendo famously didn't clean these up at all. There was some hand soldering going on, I believe, for some of the larger parts and the cartridge connector and such. And there's a lot of flux residue on here. And that's from the factory, actually. Yeah, great job, Nintendo. Yeah, let's remove the rest of the screws on the backside here, which are shorter machine screws. These also have washers. So they are used for grounding the shielding, which makes sense. So this is screwed down to this to have this act as a heatsink, which these voltage regulators actually need, at least if they are pushed a bit. And I think this is supplying all the ICs with voltage. So it's going to be stressful for the little linear regulator. And it's going to run quite warm. Might as well replace that. These are usually pretty reliable, but sometimes they fail. And in this case, it literally supplies the whole system with the operating voltage. Okay, look at that. Not too many capacitors in there. Ah, there has been leakage. I can see it. Ugh, that doesn't look great. Going to have to do some board preservation repair, I think. The pads of these surface mount capacitors are super dull, and also there's some corrosion going on there, it seems. I'm going to do some preliminary cleaning here with a Q-tip. And I think we're going to put the case parts, the plastic parts, into some soapy water, just as they are. That's our eject mechanism. And this locks the cartridge in place, actually. So you only can remove the cartridge if it's powered off. Clever thinking with very few parts there. Yeah, we're going to separate these parts. They're just clipped in. Should be relatively easy to do, he said. So this reset button is clipped in. We can take that out. This is clipped in. This should come out. Yep. And there's one screw here holding this in place. A little washer here. And yeah, the rest of it should be a matter of carefully pushing these clips in. Yep. Then we can, this just folds off basically. And this can be, yeah, this also comes off. Okay, I'm going to give this a good scrubbing in the sink and also the other parts here. I'm going to let this soak while I work on the circuit board, I think. Just using my regular kitchen sink here, some dish soap and probably some of these degreasing Silhouette Bang. And the smaller parts are going to go into a little container so I don't lose any. And I'm using lukewarm water here. Don't want to melt the plastic. So this can just sit in there for a few hours while I work on the circuit board. And then I'm going to scrub it and probably remove the remnants of the rubber feet. We're going to have to replace those. And then I'm going to show you the result. Now for our circuit board, I'm going to have to do some really thorough cleaning on this. And also, this just comes off. I think there are variants where this doesn't come off, but on this model, this just plugs in. Just some IPA here and a brush. A lot of surface mount stuff on the back. As you'd expect, because there's not a lot on the front. Or the top side. Yeah, the black parts here, that's corrosion, I think. That's no good. Yeah, I think we might want to remove the capacitors first. I'm going to take pictures of this with my phone and then look into removing these. And for removing the capacitors, we are going to use my regular desoldering station for the through-hole cap, and for the surface mount stuff, I'm going to use hot air. And then to put the new capacitors in, I'm going to use my new iFixit Fixhub portable soldering station, which iFixit sent me to try out. So I'm going to use this for this restoration. And there's also going to be affiliate links in the video description to buy these. I get a little commission for everything you buy through the links, but you don't pay anything extra. And coincidentally, or not so coincidentally, this video is also sponsored by iFixit. So I'm going to talk a bit more about this soldering station than I normally would, but I really like it and would have recommended it anyway. In fact, I did so 2 videos ago or so. So this is the Fixhub portable soldering station. Comes with a really nice soldering iron. This is literally the size of a thick pencil pen. It is super lightweight. The tips are of course replaceable. They designed their own tips to take the 100 watts of this battery pack. This is a USB-C connection. You can also run this from any USB-C port that you have, or a charger or something like that. This is completely portable. It's a battery pack, 8 hours of soldering or something like that. Heats up really quickly. It's not even cooled down yet, but there's a little switch on here. You can activate and you can see this LED ring turns red. It's fully heated up to 350 degrees Celsius, which I set it up to. So yeah, that's how quickly this heats up. It's also smart, so it goes into standby, cools off really quickly when you don't use it. It has an accelerometer in this Smart Soldering Iron, which is actually smart because all the electronics are in here, so you can set the temperature you want to use this at via the battery pack or via a web app or via an Android app. The settings are saved in the iron, so you can just use this from a USB power source of your liking. You can buy the Smart Soldering Iron separately, you can buy the portable soldering station with the iron, and you can also buy a whole soldering toolkit. This thing puts out 100 watts of power through these 2 USB-C ports. You can also charge a phone or a tablet or maybe even your laptop from this, and you can even use 2 of these irons at once from these USB-C ports. They're only going to be able to use half of the power, of course. Of course, the whole thing is made to be repairable, and there are plans online on how to do that. Super happy with this. I've been using it for a month or so, and I didn't use my old Weller soldering station since I have this. So yeah, highly recommend it. Check out the links in the video description if you want one, and also thanks iFixit. I am going to remove the large capacitor here first because that's in the way. Yeah, the black gunk there, it doesn't really wash away, so that's corrosion on the copper underneath the green solder mask. So you can see here that there's quite some corrosion on these lines here. There's a lot of corrosion going on there, so we're probably going to strip some of the solder mask and try to clean that off. I can't really clean it without removing the solder mask, so we're going to remove these caps. I think I'm just going to remove all of them in one go, and then we're going to work on the circuit board. I'm going to use some Kapton tape, which is heat-resistant tape, to tape off some of the areas around the capacitors, because yeah, I'm using hot air and there are some parts that I don't want to melt. This is just a precaution. If you have good aim, this should be fine without it. And also there's of course other methods to remove electrolytic surface mount capacitors that you've probably seen in other people's videos. I like to do it with hot air, especially if there is corrosion already. This seems to be the safest way to do things often, in my experience. Your mileage may vary, of course. This requires a bit of patience, the hot air method. So you want to heat up the pads on these slowly and carefully. Oh, there we go. That's the first one off. You want to be very careful with these pads. These are soldered too. They easily break and rip off the board. So Wait until it moves freely before you pull. So these are going to be the worst ones, the ones that are already compromised. Okay. I think those legs just broke off. Ouch. And of course things are hot. There we go. All the capacitors removed. All the electrolytic capacitors in this case. So these are the ones we removed, and I bought a capacitor kit actually from a German seller, RetroReiz. And these seem to be good quality, good brand caps. These are Rubicon. Don't know what the SMD caps are, but they are probably Panasonic or something. Some good brand, of course. And these are going to last for some decades to come. So we're going to put these in there after cleaning up the board some more. And if you need a list of capacitors that you need for a particular version of the Super Nintendo, you can look that up on console5.com. They have lists for all the revisions of the Super Nintendo, I think. I'm not going to list these in the video description this time because there are so many variants of these. I'm going to try my best to not damage anything with my solder braid, solder wick here. You don't want to put too much pressure on these pads, as I said, especially the ones that are already compromised. Yeah, didn't lift any pads. So now we're going to use a Q-tip with some alcohol to clean around the pads and on the pads, especially on the part that is corroded, and we're going to have to do some more cleanup on that. But we want to get rid of the electrolyte that is still on there, maybe. You want to be careful with these pads still, because the fibers can get caught under there and you can easily rip them out with a Q-tip. So I'm going to give this another clean with some circuit board cleaner, I think, after the fact. And then we're going to remove some of the solder mask and replace it, I think, before we do the new capacitors. So I'm going to use a fiberglass pan, glass fiber pan, to scrape off some of the green lacquer here, just to see if these connections are still intact here. There's some black gunk on here, so maybe we got some compromised copper that we need to bridge with some botch wires, but I think mostly it's going to be okay still, because it worked, as we've seen. Still, good idea to remove this, because otherwise the corrosion is going to eat further into the circuit board, and we don't want that. So now I'm going to go in with one of these. This is a glass fiber pan, fiberglass pan. Just go in there and basically work your way through the solder mask carefully and see how much damage there is to the copper. We want to remove all the black stuff basically in this case. I think our connections are still good, at least the ones I was worried about. Yeah, it's starting to look relatively reasonable. Some more work with the Q-tip and some alcohol. So now this is what I ended up with. Could do some more scraping there with the fiberglass pan, but as you can see, I've removed a lot of solder mask and a lot of the black corrosion there. So now we're going to reseal this whole part of the circuit board where we removed the solder mask, because we don't want anything to short out. So we're going to repaint this with a UV curable solder mask after checking the little connections here, but they all seem to be intact actually, so we got lucky. Doesn't look to be any damage to the traces, there was just corrosion on top of them. So we caught this one in time. So we're going to have to clean this up quite thoroughly, and then we're going to reseal it. Of course, we don't want to seal any glass fibers in there. So yeah, now repainting everything with some UV curable solder mask. You can also use nail polish, but I found the UV curable solder mask do work quite well. Just covering everything nicely. And then the parts we have to solder, we're not going to cover. Okay, not too bad. And now we need to cure it, of course. It's not going to cure without UV light. Just removing it from our pads here. So now we can put our UV light on it. And it should cure in a matter of a couple of minutes, probably. Quite literally watching paint dry. Let's see. Yeah. There's very little coming off now. So we should be good. So, next step is going to be putting the capacitors back, I think. Or rather, putting new capacitors in here, of course. So I like to put a bit of flux on all the little pads for the surface mount stuff. That is going to make it so much easier to solder. Tin one of the pads. Then we go in and slide our capacitor in. Usually you have some silkscreen that tells you the orientation. In this case, not anymore, because we removed so much of that. But we're going to be able to figure this out with the photos I took. And then I'm just going to get my tweezers and just put it on here and heat up the side that I put the solder on. And kind of slide it in place. There we go, that looks pretty nice. And then we just do the other side. That's looking good. So as it turns out, I don't have a suitable S&D capacitor in my parts bin, and it didn't come in the kit. So we're going to use a 10 microfarad 50 volt through-hole capacitor and just improvise this. This is actually, many people do it like this from the start and replace all the capacitors with through-hole capacitors. I won't recommend that because the pads are not made for this, but I'm just going to show you how I would go about doing something like this. The negative is the side with the stripe on these, and I'm just going to bend my legs here to fit the pads and solder it down basically flat to the board here. There we go, not too bad. And of course we also need the big through-hole capacitor still. Yeah, this is marked on the board. This is the negative side, which is the one with the stripe. There's a minus on the board. And we have to free up our holes a little bit more, which I'm just going to use solder wick for. So this goes in here like so. And just bending the leads here a bit outwards so it stays in place, and then I'm going to solder it in. I really want to replace the voltage regulator here. Yeah, the voltage regulator, we are going to replace this regular 7805 with a beefier version of the 7805, I think. I want to clean up the rest of this and put the heatsink back on, the shielding slash heatsink, so we can actually position this correctly. Let's put the 78S05 in there. That's a 2 ampere version compared to the 1 amp version that was in here. I gave this shielding a bit of a wipe down with some alcohol because there was some dust on there. So the old one, 7805 without any lettering. I7805. I think this is just the standard 1 amp version of these. And this is a 2 amp version that's an L78S05. And we're going to put this in here. I think I'm going to add a dab of thermal compound just because I can. There wasn't any in here originally, but it always makes for better thermal contact, and we have a large heatsink in here. And I have some thermal compound somewhere here, which is the stuff for transistors and stuff, not for CPUs or graphics cards. GPUs. You can, of course, use other thermal compound as well. So, where's my screw? I'm going to screw this down and then solder it, actually, just to make sure that we don't rip the solder again. So, that looks good. Now, soldering, don't forget that. Yep, looking good. Cleaning up my mess, unlike Nintendo. And we're going to have to put this back to be able to try our cartridge. Oh, we need the power button, of course, or the power switch. We need to put that back on its header here. And I think it should technically boot up without the front panel here connected. Let's see. Yay! Oh, and actually, the picture quality looks a lot smoother. So the recapping was overdue. Yeah, as you could see by the leaky capacitors. See if we get sound. Yup, sound also works. Yeah, but this recapping effort was successful, and our voltage regulator is also regulating the voltage correctly, it seems. Nice. So now basically the only thing left to do is to do some retrobrighting on the case and some more general cleaning. I'm going to do the retrobrighting tomorrow because it's already much too late in the evening for starting that. That usually takes a couple of hours. I am going to scrub the parts though. They've soaked long enough. I don't know how many hours I put into this, but it's been a few. So yeah, all my parts here. Just going to scrub them a little bit. They already look much better. So these parts are going to dry overnight, and I'll see you in the morning with some retrobrighting.
The next day.
I realized I made a bit of a mistake. This C59 actually is one of the 10 microfarad capacitors. There is actually a flaw in the layout of the circuit board for this revision of the PAL Super Nintendo, and that is that one of the 10 microfarad capacitors that we already replaced is supposed to be a bipolar one, so not polarized. Yeah, they actually changed that in the next revision of the PCB, and I didn't see C59 on the board there because it is in the area where everything is corroded, and I rubbed the silk screen away before I could see the designator C59. So I'm going to go back in, remove the capacitor we already put in there, and put this little MLCC multi-layer ceramic capacitor in there. Should fit fine. It's a bit fiddly because it's tiny, but yeah, that's better. That's one of the ones that leaked the worst, so probably it's a good idea to put a bipolar capacitor in there according to the specifications. And a ceramic capacitor instead of an electrolytic capacitor won't hurt. It was in the kit, we're going to put it in. This one here is the culprit. So they had enough 10 microfarad electrolytic capacitors in there. was just my fault. There we go. So one side. Sorry, this is impossible to film while I'm doing it, I guess. So this ended up like this. It's this capacitor, this is literally, I don't know, a millimeter wide or something. And I just put solder on the pads and bridged it in there, basically. That should be 10 microfarads for this position. I'm going to briefly test that, of course. Giving me a PAL signal. Yep. It still works. Yeah, okay, so that was a little oopsie on my part. The capacitor set was actually excellent. It was better than the capacitors that were on here originally. So now we can put this aside and work on the case parts that should have dried by now. Yeah, these look a lot cleaner now because we soaked them, and there are some parts that need some retrobrighting. The light gray parts need a bit of retrobrighting, and the dark gray parts I'm just going to leave as is. I also forgot this part here, which is slightly yellowed, so let's see if we can take that off. I think it's a separate part. Yep, it's just clipped in. So this part is going to get a quick wipe. I forgot to soak this. This is supposed to be the color of the whole thing. And interestingly, it is yellowed from the inside and the outside. So it's not only UV that did this. And I want to remove these rubber feet here. These are nasty and gooey still after washing. Yeah, that's not going to be pretty. It's all kind of goo. Yeah. That's not going to work very well. Maybe we can just cut them off. These are very, very sticky and kind of welded to the case there. Not sure how to remove these actually. Maybe I'll just leave them on. I'm just going to cut them off basically and put something new on there, I guess. Oh, we lost a part. This plastic is super brittle. Yeah, I'm just going to cut these off and then glue something on them to hide the goo, or use the goo as glue. I'm just going to glue this part back on before I do the retrobrighting, I think. That's this here. I think I'm just going to put some plastic glue on there. The screw post thing I'm going to glue back once the retrobrighting is finished, so we can maybe see some color difference there, I guess. And I'm using Uhu Plast Special, which is a plastic model making adhesive. Actually, that works pretty well for most kinds of plastic. Just putting a tiny bit on here. Putting this down, and I have to remove the excess, I guess. This melts the plastic and usually forms kind of a weld bond. Oh. So we're going to have to leave this and wait for it to settle. Yeah, much of this is not even going to be visible, the whole center part of this. So I'm not going to go berserk on that with the retrobrighting. This needs a bit of a wipe. You always want your plastics to be clean before you retrobright them. And then we're going to get out the retrobrighting box and the hydrogen peroxide. I am going to use this peroxide cream, 12%. That is from the hair industry. And we're going to use some cling wrap to put our parts in. I made a whole video about the process, so I'm not going to go into much detail here. I'm just going to link the video in the video description in case you're interested in my retrobrighting process that works for me. Just going to evenly coat this whole thing. At least the parts that are visible. I'm not going to bother with the inside there. And then we just wrap it in cling wrap. Like so. And we're going to do the same for all the other parts. I like to put some on my cling wrap before I put the parts in there, just to spread it more evenly. And in my experience, you don't have to worry about stickers or printing too much with this process. There we go. And now all the parts can go into my retrobrighting box. This is my retrobrighting box. Just basically a mirrored box that has a black light LED strip in there. And we're going to put the parts in there so that that the light can get to them evenly. And we're just going to turn this on, wait for half an hour, and then come back in and spread the cream around a bit under the cling wrap, just to make sure we don't get any discoloration or streaking or anything like that. So this has UV light in there, and we are also going to put a so-called grow light on top here. That is going to be shining this kind of light in there. And the LED strip is going to be lit as well. And half an hour later I come in and just massage the cream slightly so it doesn't accumulate in certain spots and makes things streaky. And that's basically it. And then you wash the parts thoroughly and dry them again, and we should be good to go, hopefully. And the whole process usually takes a few hours depending on the degree of yellowing you have. But usually you get some quite nice results with this method. Or in my experience, I get some nice results with this method that I've been using for years. So my hopes are quite high, but we're going to see how it turns out. The plastic seems to be super compromised. No idea if this is going to work. We'll see. I'll report back. So I've been retrobrighting this for 1.5 hours now, I think, and it's starting to change slightly. So the yellowing is slightly going away. Might be a couple of hours still in this box. I went through some of the parts again, and unfortunately I lost a little tiny part, and that is the LED diffuser thing, kind of a very small piece of translucent plastic that's under the power LED in the Super Nintendo. It fell out, I think. It's just sandwiched between two of the layers of the case, and it's just a loose part, and I must have dropped it somewhere. Worst case, it went down the drain while I washed the parts. Anyway, long story short, I can't find it, and I'm going to have to build a replacement. And for that, I'm going to use 3D printing, because I have a 3D resin printer set up here, right out of frame. I don't have any completely clear resin though. I have like gray translucent resin. I think I'm going to use that and see how it looks. And I'm just going to start the printing process while I'm still retrobrighting, because I'm working with dangerous chemicals anyway, so why not add some more dangerous chemicals? Oh, and I forgot to mention, of course, there are several 3D models that other people already made, so I'm going to link to one of them that I'm going to use in case you lost your LED diffuser too, which seems to be a common problem, judging by some forum posts and things like that that I saw. And I think I'm going to print 2 or 3 of these at once, because you never know. So after washing and drying the case parts again, they are significantly better now. Yeah, it's nearly back to the original color. Unfortunately, this part here is a bit brighter than the rest. This is basically the original color, but the rest is still a tiny bit yellowed, but it's definitely way better than it was. And I'm super satisfied with the result, given that this was super yellow when we started the process. So yeah, the magic of retrobrighting did its thing again. And now we're going to have to glue this part here back. Yeah, we're going to have to reconstruct this a bit. And then we can get to the fun part, reassembly. But first we're going to have to use our plastic glue that I used before to glue this standoff back in. Yeah, I'm first going to probably reassemble this part here, let it dry for a while and then do the rest of it. The other part we glued held up just fine, so I have high hopes that we can just get this back to its original strength basically and hopefully get a screw back in. Looking good so far. And probably I'm going to put a bit of heat shrink tubing over this just to stabilize it a bit more. I'm just going to put this back into the casing now. Usually you can feel the exact position of these quite well. And this part goes in here like so. This is what it looks like now. Yeah, so basically as good as new, I guess. Yeah, we can totally put some heat shrink tubing over all of these standoffs, I think. Just little pieces of heat shrink tubing. But first I'm going to let the glue settle for a while. That should make things a bit more stable, hopefully. Yeah, and I'm probably not going to risk putting heat on this actually. So yeah. As for our gooey rubber feet, I found these in my parts bin. They're just foam rubber with a sticky back, and they fit quite nicely onto our old stands here. So we're just going to use these and hide the old stuff there. And they look rather original. This is going to be fine. Yeah, perfectly fine, I think. So these little things go in these cards. So the spring-loaded mechanism, there's a little cutout in this white part, and there's a little hole in this post here where the other end of the spring, these angled things go in. Now it's nicely spring-loaded. I think that's how it's supposed to go. So our LED replacement part, which looks rather nice, should fit in here. Yes, it does. And this goes in so. Yeah, it actually looks pretty cool. It's gripping. Hey, no cracking noise. So there we go. I think it looks great. At least much better than it was, which was the whole intention. So this is how it looked. Going to edit in some old footage, and this is how it looks now. The color of this part is a bit brighter than the rest, as I mentioned, but overall it looks really good. Quite even, still a bit more yellowing in the back, but yeah, definitely looks much nicer than it was. Okay, let's see if the mechanics still work and how our LED looks. Ooh, nice. It actually looks super cool. And it still works! I need some better controllers. These are very cheap knockoff controllers, not even original Nintendo ones. And they are super worn out. But for testing, it's going to be okay. Not much fun to play with these actually, but yeah, it still works fine and it looks amazing. And I actually really like the look of the LED there. It looks much better when it's off because it's nearly black. And then when I turn it on, you can still see the LED shining through there. It's pretty cool actually. Maybe I'm going to replace this with a proper clear resin printed part, but for now I'm very, very happy with how this turned out. And the eject button feels much smoother than before. Yeah, I think that's it for today. I hope you enjoyed this deeper dive into Super Nintendo restoration than I intended it to be. But as you've seen, there were so many things that were slightly wonky and the circuit board needed a total reworking. I thought it would just be replacing the capacitors and be done with it. But this restoration required most of the skills I learned over the years. So maybe there's some hints that you got from this. Let me know if you have Super Nintendos that you restored or plan on restoring in the comments. Thank you so much for your time. If you aren't subscribed to this channel, please consider doing so because it really, really helps with getting cool sponsors and being recommended to more people by the algorithm. That's just how things work. Special thanks, as always, to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page. The links to that are on my website and in the video description. And without you, these videos wouldn't be possible, as you probably know. So thank you very, very much. That's it. I'm Jan Beta. Thanks for watching. See you next time. Bye.